Let's begin with a new topic in maths today. We will learn about infinity. So let's subscribe this channel now. So we begin with a simple but powerful image. A child standing on a long straight road that seems to stretch forever. So the question appears on a screen, does this road ever end? This is how most of us first imagine infinity, something that keeps going or never stops. Then the camera zooms out into deep space, filled with countless stars and galaxies. The question changes, is the universe infinite? Now infinity feels bigger, not just a long road, but endless space itself. Next we see numbers 1, 2, 3, 4 running forward endlessly. They don't stop, they just keep going. The message is simple, counting never ends. No matter how far you go, you can always add one more number. Suddenly a glowing infinity symbol appears in the sky. Now the big question comes forward, what is infinity? A student writes on the board, infinity plus 1 equals to what? He looks confused. Is that infinity just another number? Can we add to it like b5 plus 1? The teacher dramatically erases the board and explains, infinity is not a normal number. This is important. Infinity does not behave like ordinary numbers. It is not something you can calculate within the usual way. It represents something without limit. Now we see a staircase going up into the clouds, never ending. The message reads, without limit, this is the true meaning of infinity. No boundary, no final step. A boy starts stacking blocks, 1 plus 1 plus 1 plus, he keeps adding. The pile grows taller and taller. The idea is simple. You can always add one more. Numbers never run out. Then we see two lines of characters, natural numbers on one side and even numbers on the another. The question appears, are all infinites equal? It seems obvious that even numbers are fewer since they skip half the numbers, but something surprising is about to happen. The next visual showing the 1 pointing to 2, 2 pointing to 4, 3 pointing to 6. Every natural number matches exactly one even number. This 1-to-1 matching reveals something shocking. A shocked face appears, same size infinity, even though one set looks smaller but go on forever. And mathematically they are considered the same size. Now a thoughtful mathematician appears. The text reads, some infinites are bigger than others. This challenges everything we thought we understood. How can one infinity be bigger than another? We zoom in between the numbers 1 and 2. Suddenly endless decimals appear, 1.1, 1.01, 1.001, 1.0001. So the message between 1 and 2, infinite numbers. Even within a tiny space, there are infinitely many decimal numbers. The decimals multiply rapidly across the screen. Real number equals to bigger infinity. This shows that the infinity of near numbers is larger than the infinity of counting numbers. Not all infinites are the same. Next, a rocket flies upward with x equals to infinity written behind it. This represents calculus. As x grows larger and larger, it does not reach infinity. It just keeps increasing without bound. Then we see 1 by 2 plus 1 by 4 plus 1 by 8 stacking closer and closer to 1. Surprisingly, even though the process continues forever, the total approaches a finite value. Infinite steps, finite result. Infinity does not always mean something becomes infinitely large. Sometimes an infinite process can approach a limit. A pie gets cut into smaller and smaller slices. The slices never disappear, they just keep shrinking. This shows how infinite division works, smaller and smaller forever. But then the infinity symbol crashes through it. But infinity is bigger. No matter how large a number is, it is still finite. Infinity is not just very large. It has no end at all. Now we arrive at a hotel with endlessly numbered rooms. 1, 2, 3, 4. The sign says, Hilbert's Infinite Hotel. Every room is full. A blinking sign flashes, no vacancy, yet a new guest arrives. Guests begin shifting rooms forward. Room 1 moves to room 2, room 2 to room 3, and so on. Suddenly room 1 becomes empty. Problem solved, even though the hotel was full. So it can still fit more guests. That's the strange logic of infinity. Then infinite buses arrive, each carrying infinite passengers. Somehow, through clever rearranging, everyone still fits. Infinity behaves in ways that seem impossible in the real world. Next, we see a black hole pulling everything inward. The caption reads, infinite density. In physics, equations sometimes predict infinities at the center of black holes. A scientist scratches their head, or incomplete physics. Maybe infinity here signals that our theories are not complete yet. Now we zoom into the surface of a circle. It has no edge, no boundary, yet it is finite in size. The text says, finite but unbounded. This introduces a subtle idea. Something can be limited yet have no edge. A brain expands with the stars inside it. Infinity stretches the mind. The concept pushes our thinking beyond everyday experience. A question mark slowly transforms into the infinity symbol. Does infinity really exist? Is it real or just a mathematical tool? Finally, the camera zooms out endlessly into space. Once more, stars fade into darkness. The last message appears. With infinity, there is always more. And this is the beauty of infinity. No matter how far you explore, there is always something beyond. It challenges logic, reshapes mathematics, and expands imagination. Infinity is not just about numbers, it is about understanding the limitless possibilities of thought itself. So, for more interesting ideas for the mathematics, you can subscribe this channel now.